In early 2024, on a contested stretch of battlefield in eastern Ukraine, a Russian armored vehicle rolled forward along a route that had been declared safe. Engineers had cleared it. Markers were placed. Other vehicles had already been lost nearby, but this lane was verified. The column moved with confidence. Seconds later, the vehicle exploded. There was no dramatic breakthrough, no massive offensive, no historic speech. Just steel torn open in a place that was supposed to be secure. What happened next did not simply destroy another armored platform. It exposed something far more unsettling. On today's battlefield, certainty is disappearing. Routes that are cleared are not safe. Armor that is reinforced is not secure. Darkness no longer hides movement. And this is only the beginning. A Russian armored vehicle moved forward along a lane that had been marked safe, and seconds later it detonated a mine. That moment tells us something important about how mine clearance works today, and why it no longer gives the same level of certainty it once did. In traditional mechanized doctrine, breaching a minefield follows a clear process. Engineers use mechanical rollers, explosive charges, or manual teams to clear a path. Markers are placed to guide following vehicles. Commanders then push armor through that corridor to regain momentum. The purpose is not only to remove explosives, but to restore confidence. A cleared lane is supposed to signal control. It tells the driver that someone has already taken the risk, done the work, and secured the ground. In past wars, once a route was opened, units could move with relative assurance that the danger had been reduced to a manageable level. However, the battlefield in Ukraine no longer behaves like older battlefields. Rapid remining has changed the equation. Mines can be deployed quickly, sometimes by artillery, sometimes by remote systems, and sometimes through methods that do not require large engineering units. Scatterable mines can be spread across wide areas in minutes, creating overlapping fields that are difficult to map accurately. Even when a lane has been checked, new devices may already be in place by the time vehicles move. Electronic interference adds another layer of risk. GPS signals can be disrupted, and digital maps may not match the reality on the ground. What was verified earlier in the day may not reflect the situation hours later. This means that a marked route does not represent permanent safety. It reflects a temporary condition in a constantly shifting environment. The deeper issue is psychological. Mechanized warfare depends on predictable corridors. Tanks and armored personnel carriers are designed to move with speed and coordination, and their strength comes from combined action and forward pressure. When a driver sees a marked path, he expects that path to hold. If that expectation fails, the effect spreads beyond one vehicle. Crews begin to doubt the markings. Commanders hesitate before committing additional forces. Each pause allows the opposing side to observe, adjust, and prepare. Tempo, which is the lifeblood of armored operations, begins to fade. Even a short delay can break the rhythm of an advance, and once that rhythm is lost, regaining it under fire becomes much harder. Confidence is not an abstract idea in combat. It is a practical factor that shapes how quickly units move and how boldly they act. This incident also signals something strategic. The battlefield is no longer static, where obstacles remain fixed and front lines move slowly across known terrain. Instead, it is continuously reshaped by unmanned systems and remote delivery methods. The ground is influenced by what happens in the air, especially at low altitude. Small drones can observe engineering work, track movement, and guide indirect fire. Mines are not just physical objects placed once and left alone. They are part of a broader network of surveillance and response. The side that can see more and adjust faster effectively redesigns the terrain in real time. In this environment, clearance becomes an ongoing contest rather than a completed task. For American viewers who have followed decades of armored doctrine, this is a serious development. Traditional breaching assumed that once engineers opened a lane, maneuver units could exploit it before the enemy reacted. Now the reaction can be immediate, and sometimes invisible. The marked route that detonated under that Russian vehicle was not simply a technical failure. It reflected a shift in how control over space is contested. Physical effort alone no longer guarantees security. Constant awareness and protection from remote threats are now essential. And when a vehicle is immobilized today, the story does not end there. In fact, immobilization is often only the beginning of a far more precise process. After the vehicle is disabled, Ukrainian UAVs move in quickly, and FPV drones together with grenade-dropping drones are used to complete the destruction by targeting weak points or open hatches. This is not random violence, and it is not chaos. It follows a clear and repeated pattern that has become visible across many engagements. First, a mine or another obstacle stops the armored vehicle and removes its mobility. Once it cannot move, a reconnaissance drone confirms the damage and checks whether the crew is still inside. Then, an FPV drone approaches at low altitude and strikes a vulnerable section of the hull. If that hit does not fully destroy the target, a second drone may drop a grenade directly through an open hatch or onto a sensitive area. Within minutes, a disabled machine turns into a burning wreck. This layered kill chain shows how modern battlefield action unfolds step by step, and each step has a clear purpose. The initial explosion does not need to destroy the vehicle outright. It only needs to stop it. Mobility is life for armored platforms, and once movement is lost, time works against the crew. A surveillance drone hovers above and transmits live video, allowing operators to study the scene. The FPV pilot then guides his aircraft toward a precise location instead of aiming at the strongest armor. If the strike hits a structural gap or a thinner section, damage spreads quickly. When a grenade is dropped into the interior through an exposed opening, the effect can multiply. Fire grows inside a confined space, and pressure builds in areas where ammunition and fuel are stored. What begins as a simple hit often turns into a chain reaction. Targeting discipline is one of the most striking elements in this pattern. Operators do not attack blindly. They search for specific points such as the turret ring, which connects the rotating turret to the hull. They aim at the rear engine deck, where protective thickness is often lower than at the front. They look for open crew hatches, especially when soldiers attempt to escape or check the damage. They also consider the location of ammunition storage inside the vehicle. These choices are based on practical knowledge, not guesswork. Videos from the front show drones circling briefly before diving, which suggests that the pilot is making a final decision about where to strike. This level of focus reflects training and repetition. When internal detonation occurs, the result is usually dramatic. Ammunition cook-off can follow a direct hit, and secondary explosions may erupt seconds after the first blast. Flames push outward from the turret or from the rear compartment, and thick smoke marks the vehicle as a total loss. In many recorded cases, once the ammunition ignites, recovery becomes impossible. Even if the hull remains partly intact, the heat and internal damage make repair unlikely in field conditions. For armored crews, the fear of such a reaction is real, because once it starts, control is lost almost immediately. The operational consequence of this system is clear. In previous wars, a damaged tank could sometimes be towed away and repaired behind the lines. Recovery teams would work under cover of smoke or artillery, and vehicles returned to service after maintenance. In this conflict, immobilized machines are systematically finished before any rescue attempt can succeed. Drones remain overhead and watch for movement, and if recovery equipment approaches, it may become the next target. This changes how commanders calculate risk. Sending armor forward now carries the additional danger that even a small setback can lead to complete loss within minutes. There is also a strong economic imbalance in this equation. An FPV drone may cost a few hundred or a few $1,000s, while a main battle tank or a self-propelled gun can be worth millions. When a low-cost system disables and then destroys high-value equipment, the financial pressure becomes significant. Production capacity, supply chains, and replacement speed begin to matter as much as battlefield skill. For viewers who follow defense budgets and procurement debates, this imbalance raises important questions about sustainability. Faced with this pattern of destruction, Russian forces did not remain passive. They adapted. But adaptation came with new vulnerabilities. T-72 and T-80 tanks, reinforced with metal plates, steel cages, and KMT-7 mine rollers, have become a visible symbol of adaptation on the modern battlefield. These modified vehicles, sometimes called turtle tanks, show how crews and engineers respond under pressure when traditional protection no longer feels sufficient. Instead of relying only on factory armor, additional layers are welded onto the hull and turret in the field. Slat armor surrounds the upper structure, metal sheet enclosures cover exposed sections, and extra grating is attached to reduce the impact of incoming threats. The goal is simple: increase survivability against mines and anti-armor weapons that strike from unexpected angles. These structural modifications follow a clear logic. Slat armor is designed to disrupt shaped charges by causing premature detonation before the main armor is reached. Metal sheet enclosures attempt to block or weaken drone-delivered explosives. The KMT-7 mine roller, mounted at the front of the tank, is meant to trigger pressure-activated mines before the vehicle's tracks roll over them. By detonating explosives several feet ahead, the crew hopes to reduce damage to the hull. In theory, these additions create a layered defense system that combines mechanical clearance and passive protection. Each component addresses a specific threat, and together they aim to restore confidence to crews operating in heavily mined areas. Some vehicles also carry electromagnetic mine triggering systems, which are designed to activate magnetic mines early. These devices create a magnetic field in front of the tank, simulating the presence of a large metal object so that certain mines explode before direct contact. The idea is to push the blast away from critical components and limit structural harm. In technical terms, this adds another layer of prevention, and it shows how technology is being used to counter increasingly complex mine designs. However, these systems do not guarantee full safety because not all explosives rely on magnetic triggers. Pressure-based and command-detonated devices remain dangerous even when magnetic fields are present. While these adaptations may increase protection in certain situations, they introduce serious trade-offs. Added metal increases mass, and increased mass reduces maneuverability. A heavier tank accelerates more slowly, changes direction less easily, and consumes more fuel during operations. Reaction time also suffers, especially in areas where rapid movement can mean the difference between survival and destruction. Larger structures create a more visible silhouette, and the added weight places stress on suspension and engine systems that were not originally designed for such loads. These practical limits affect how effectively the vehicle can perform its intended role. There is also the issue of thermal and visual exposure. Extra plating and cage structures alter airflow around the vehicle, and heat from the engine and exhaust may become more noticeable in certain conditions. In open terrain where cover is limited, a slower and bulkier platform can become easier to track from above. Protection against mines does not automatically translate into protection against aerial threats. When moving across exposed fields, these reinforced tanks may survive a ground explosion, but still remain vulnerable to observation and attack from low-flying systems. The battlefield is no longer defined only by horizontal threats. Vertical danger now plays a central role. From a doctrinal perspective, these modifications suggest reactive adaptation rather than long-term strategic redesign. Field upgrades reflect urgency, not comprehensive reform. Crews respond to immediate challenges by strengthening what they have instead of replacing the system entirely. This approach can improve survivability in the short term, yet it does not remove the underlying pressure created by new forms of attack. For American observers who study armored doctrine, this raises familiar questions about balance. Protection, mobility, and firepower must remain aligned because improving one factor often weakens another. Armor thickened, rollers spun, magnetic systems activated. But none of these adjustments address the most disruptive factor emerging on the battlefield. FPV drones equipped with RPG-7 warheads and KZ-6-shaped charges capable of penetrating armor have become one of the most disruptive tools on the modern battlefield. These are not large aircraft or expensive missiles. They are compact systems that carry a payload of about 1 to 2 kilograms, yet they can travel distances of up to 10 kilometers while transmitting live video back to the operator. Pilots often wear VR headsets, which allow them to guide the drone in real time, as if they were sitting inside the aircraft. This setup gives them fine control, quick adjustment, and the ability to react to sudden movement. What used to require heavy launch platforms can now be delivered by a device that fits inside a backpack. The technical capability of these systems lies not only in their range or maneuverability, but in the type of explosive they carry. A shaped charge such as the KZ-6 focuses explosive energy into a narrow jet, which allows it to punch through metal instead of spreading force outward. RPG-7 warheads operate on a similar principle, and when mounted on a drone, they become guided projectiles that can be steered toward specific points. Concentrated penetration is the key advantage here because even strong vehicles have thinner areas that can be exploited. When the jet enters the interior compartment, it can ignite fuel, damage critical components, or set off stored ammunition. A small device, if placed precisely, can produce a chain reaction that ends in total destruction. The strike profile of these drones adds to their effectiveness. Instead of approaching from the front, where armor is thickest, they often dive from above in a top-down attack. Many armored vehicles are less protected on the roof because designers historically expected threats to come from horizontal angles. Operators also aim for the rear engine section, which houses mechanical systems that keep the platform mobile. In some cases, they steer directly toward an open hatch, especially if crew members have exposed that point during combat. These choices are deliberate, and they reflect a shift in how vulnerabilities are identified and exploited. Precision replaces brute force. From a strategic perspective, the asymmetry is striking. A single FPV drone may cost a fraction of the price of the vehicle it targets, yet it can eliminate equipment worth millions of dollars. Low cost combined with high precision creates pressure that extends beyond the battlefield. Military planners must consider not only how to defend against such systems, but also how to sustain production under constant losses. Scalable manufacturing becomes critical. When thousands of units can be assembled and deployed over a short period, numbers begin to shape the outcome. Quantity does not replace quality, but it amplifies impact when accuracy is already present. The industrial dimension of this development cannot be ignored. Drone manufacturing has become part of the broader war economy, with workshops, private firms, and volunteer groups contributing to output. Components are sourced, assembled, and modified to meet tactical needs. Software updates improve navigation, while field feedback leads to design changes. This cycle of adaptation and production creates a steady flow of new platforms ready for deployment. It is not a static system. It evolves continuously. For observers who follow defense trends, this integration of civilian technology into combat roles highlights how modern conflict blurs the line between military industry and commercial innovation. In practical terms, these drones reshape expectations about armor survivability. Traditional doctrine assumed that thickness and slope would determine endurance. Now, angle of approach and operator skill matter just as much. Even well-protected platforms must operate with greater caution when small, agile devices can approach from directions that were once considered secondary. The battlefield becomes three-dimensional, and threats arrive from above, behind, or through openings that were never designed to withstand such attacks. But these drones are rarely used alone. Their true impact appears when combined with other systems. FPV drones strike lead vehicles, disrupting formations, followed by artillery or secondary drones, and this sequence has become one of the most effective patterns seen on the battlefield. The first target is often the vehicle at the front of a column, because once it is hit, movement behind it slows or stops. When the lead platform is disabled, the rest of the convoy cannot easily pass, especially on narrow roads or in mined areas. Traffic congestion forms quickly, and drivers hesitate while waiting for orders. In those moments of uncertainty, confusion spreads through the formation, and coordination begins to weaken. A single impact can change the rhythm of an entire operation. This approach is not random. It is designed to break momentum. Mechanized doctrine depends on speed and cohesion, and armored units are trained to push forward together so that firepower and protection work as a combined force. When the front vehicle burns or blocks the route, the rest must decide whether to advance, reverse, or dismount. Each option carries risk. A delay of even a few minutes can give the opposing side time to prepare the next strike. Drone operators observe this hesitation from above, and they relay coordinates to artillery units waiting in range. Correction is often made in real time, because the drone can adjust fire after each round. What begins as one hit turns into a coordinated engagement. Follow-up fire plays a decisive role. Artillery shells land near stalled vehicles, increasing pressure and forcing crews to abandon cover. Secondary FPV strikes then target those that attempt to reposition. Grenade-carrying drones may approach damaged machines to ensure they cannot be recovered later. This layered response does not rely on a single system. It combines surveillance, precision attack, and indirect fire into one continuous action. Each element supports the next, and together they create an effect greater than any one tool alone. Under these conditions, mechanized doctrine comes under serious stress. Armored warfare is built on the idea of momentum, because moving quickly reduces exposure and overwhelms defenders before they can react. When drones interrupt that flow, they remove the advantage that heavy vehicles are meant to provide. A halted column becomes a cluster of stationary targets. Commanders who once relied on speed must now factor in the constant threat of aerial observation. Even a well-planned advance can unravel if the lead vehicle is struck at the wrong moment. Tactical paralysis often follows. Vehicles stop, troops dismount to seek cover, and exposure increases in open terrain. Infantry may scatter into nearby tree lines or trenches, but movement itself can be tracked from above. Crews who remain inside risk further hits, while those who exit face artillery fire or additional drone strikes. The decision cycle becomes compressed, and choices must be made quickly under pressure. For viewers who study armored engagements, this pattern shows how small systems can impose large effects without matching the size or cost of traditional weapons. This combination of disruption and follow-up fire signals a broader change in how engagements unfold. Instead of relying solely on massed armor or heavy bombardment, forces now integrate small aerial platforms into every phase of an operation. The battlefield becomes a network where information flows rapidly and response follows within minutes. For decades, darkness provided protection for advancing forces. That protection is now fading. Night vision and thermal drones remove darkness as a shield, and this shift has changed how operations unfold after sunset. For decades, advancing forces relied on limited visibility to reduce detection, because once the sun went down, observation became harder and movement felt safer. That assumption no longer holds. Thermal detection allows operators to see heat signatures clearly, and vehicles emit strong heat from engines, exhaust systems, and friction on moving parts. Even when headlights are off and engines run at lower power, infrared sensors can pick up warm outlines against cooler ground. What once looked like empty terrain to the naked eye now appears active on a thermal screen. Infantry units also face new exposure at night. Soldiers moving through tree lines may believe foliage hides them, yet thermal cameras detect body heat through gaps in vegetation. Positions inside shallow bunkers or behind thin walls can be identified by differences in temperature. When troops gather in small groups, their combined heat makes them easier to spot. This does not mean concealment is impossible, but it requires far greater discipline and planning. For viewers who follow battlefield technology, the lesson is clear. The fight does not pause when light fades. It simply shifts to another spectrum. Night FPV operations add another layer to this change. Drones equipped with infrared cameras can approach quietly at low altitude, and their electric motors produce minimal sound compared to larger aircraft. Short-range strikes become possible even in total darkness, because the operator can see through a headset what the human eye cannot. A vehicle parked under cover of night may still be tracked, and a stationary position may be targeted without warning. The element of surprise, once tied closely to time of day, now depends more on signal control and electronic awareness. The psychological impact of this development is significant. No safe hour, no safe direction. Crews who once preferred night movement must now consider that they are visible from above at any time. This constant exposure adds strain and forces units to rethink how and when they advance. Close-range drone dominance changes how armor approaches contested areas, because visibility from the air removes the protective value of darkness. Taken together, these developments do not signal the end of armored warfare, but they do signal something equally profound. The explosion on that supposedly safe route was not an isolated accident. It was a warning, and the events that followed showed why Russia now faces a serious disadvantage on this battlefield. First, a vehicle advanced with confidence, then it was stopped, and within minutes the situation turned against it as layered attacks erased any chance of recovery. That pattern repeated across open fields and at night, and each time the message was clear. Heavy armor alone no longer guarantees control. Low-cost aerial systems compress reaction time, expose movement, and punish hesitation. And this shift forces Moscow to spend more resources just to move a few miles forward. For viewers who follow military trends, the lesson is direct. Adaptation must be faster than threat evolution. If you want clear analysis on how these changes shape global power, subscribe to Military Force and stay informed.